All right, so here's another application number 76. It says the width of a rectangular gate is 2 meters larger than its height. The diagonal brace measures root 6 meters. Find the width and the height. All right, so we want to find the width and the height, and we have this phrase here that says the width is 2 meters larger than its height, right? So usually if you have something that's than it's, or 2 meters larger than it's, whatever that comes after the than is going to be the x usually. Okay, hopefully that made sense. Sounded good in my head before I said it. So that's going to be our x. So x is going to be the height. All right, and then we can make the width. Let me go back. So since it says the width is 2 meters larger than, that means x plus 2 will be the width. All right. So one thing that's always helpful to do is draw a picture, right? So if we have a rectangular gate, so we have this gate here, right? Some rectangle here, and the width is x plus 2, right? 2 meters larger than its height, so its height is x, width is x plus 2. Okay, and then we have this diagonal brace, right, that's coming across, and it measures root 6, so they tell us what this is. So then find the width and the height. So we have a situation here where we have a rectangle, and within that rectangle, and well, let's start with, since it's a rectangle, we know that we have right angles, all the corners are 90 degrees. And within that rectangle, we have a triangle, right? So we have this right triangle. And whenever we have a right triangle, there's a certain theorem that holds, right? We know that a squared plus b squared equals c squared. All right? And so that's a relationship. So we have an a, a b, and a c, right? So we can plug the values in terms of x into our Pythagorean theorem. So instead of a, I'm going to put x squared. Instead of b, I'm going to put x plus 2 and square it. And instead of c, I'm going to put root 6. So there's our quadratic equation. Okay, so now we don't need the words anymore. We really don't need the picture anymore. But that's how we set it up. All right, and so now I'm going to simplify. So remember that when we're expanding a binomial, we do have a shortcut. We know that a plus b quantity squared is a squared plus 2ab plus b squared. So I'm just going to bring down the x squared here, and then to expand this, I'm just going to square the first term. The middle term is x times 2 doubled, right? So x times 2 is 2x. If I double that, I get 4x. And then I'm going to square the second term, and so 2 squared is 4. Okay. Then on the other side, I have root 6 squared, so we know that square root of, or square of a square root, we just get the radicand. All right, so now we can combine like terms. So I have x squared plus x squared, and then I'm also going to subtract 6 from both sides to get one side to be 0. So 2x squared plus 4x minus 2 equals 0, right? So a couple things here. If I want to use a quadratic formula, I can just start right away and do that. If I want to factor, then I want to try to factor out any common factors, right? Or even, I can even divide by a common factor because we have an equation, right? So I see that 2 goes into all these, so I can divide everything by 2, or I can factor out a 2, and I'll end up with x squared plus 2x minus 1 equals 0, right? So if we want to factor this, we want to find numbers we can multiply to get 1, negative 1, or multiply to get 1 that we can subtract to get 2, right? So only two things we can multiply to get 1 are 1 and 1. And 1 minus 1 doesn't equal 2. So this is not something that we can factor. All right, so we're stuck with the quadratic formula. We could also complete the square. We can't use the even root property because we have an x squared and an x, right, term. So if you have an x squared and an x term, you can't use the even root property. All right, so I'm going to use the quadratic formula. So I'm going to say x equals negative b plus or minus the square root b squared minus 4ac all over 2a, right? So a in this case is 1. So I'm going to put that after the 4 and underneath. B is 2. So I'm going to put that in the first 2 spots. And C is negative 1. So I'm going to put that at the end. Okay. Now remember that you could have actually used these values and you'll get the same answer. So if you want to use 2 for A, 4 for B, and negative 2 for C, you'll get the same result. Okay. All right, so now I'm going to work this out. So I'll get negative 2 plus or minus. Underneath the radical would be 2 squared, which is 4 plus 4, right? So 4 plus 4 is 8. And we can see 8's not a perfect square, so that confirms that we weren't able to factor. All right, so that's what I have. And then I can simplify the radical. So root 8 is 2 root 2. Can divide everything by 2 here. So I'm going to get negative 1 plus or minus 1 root 2. Okay. And so now I have 2 possibilities. Did it say to round here? No. Okay. So I have 2 possibilities, right? One answer is negative 1 plus root 2. And the other answer is negative 1 minus root 2. So which one of these doesn't make sense in the context of a rectangular gate? That's right, because we can't have a negative, right? We're not going to have a negative length. And so this one is the only one that comes out to be a positive, right? So that's our height, right? Oops. So that's our height. And so now, in order to find our width, we have to use x plus 2, right? So the width is going to be negative 1 plus root 2 plus 2, right? Which turns out to be, combined like terms, it'll be 1 plus root 2. All right, so those are 2 values. And then one more thing, don't forget your units. So we see here that we're talking about meters. So make sure you include your units. So it'll be negative 1 plus root 2 meters, negative 1, and then positive 1 plus root 2 meters for the width. Okay. Now remember, you can plug those in your calculator and get a decimal approximation. Since they didn't say to round, we're just going to keep it exact, but that might be something you do at some point. All right, shoot me any questions if you have them on this. So here's something you can freeze if you want to, but just kind of a step-by-step in terms of how to solve application problems. So you can freeze this for your notes. And so let's do one more thing. I just want to summarize when to use each of these, right? We talked about it earlier, but even root properly can always be used. No. When should it be used? Or when at least maybe can it be used, is when you have a x squared term, or that squared could be any kind of even power, but in the case of a quadratic, it's going to be an x squared, right? With no other x term, right? So you could have 2 x squared terms because you can combine them and make them to 1, but you won't have an x to the first term, right? You won't have another x term. Okay, and so that if you have that situation, even root property is pretty easy, right? Maybe one of the more intuitive ways, because you can just isolate the variable, take the square root of both sides. Don't forget on this one though, don't forget the plus or minus. Okay. Okay, then for factoring cannot always be used, right? When should it be used? So I would say if you have a simple quadratic, if you're comfortable with that, I think, you know, that's a great way to go, right? And remember, you're looking for numbers you can multiply to get C that you can add or subtract to get B, right? Okay, so C is the key term that you're looking for, okay? If it's a complex quadratic, then it kind of depends, right, on your kind of your tolerance or your threshold for you know, paying on on a complex quadratic. I mean, in my case, I don't, you know, I kind of like doing them, but you know, not everybody does. So, but this is when we have to multiply A times C, and then you get a number there, and you try to find numbers you can multiply to get that you can add or subtract to get B, right? And so, so if you're comfortable with complex quadratics, and that's easier for you than the quadratic formula, you can do it that way too. Okay, so all right, but remember that they have to work, right? Another way to check on these is you can use the discriminant. If the discriminant, that says discriminant there, is a perfect square, that's when the factoring method works. Okay, completing the square, can it always be used? Yes. And I would say, you know, when should you use it? If you preferred over the quadratic formula. Okay, otherwise, you know, there's not really a huge, unless it's set up nicely, right? If it's set up to be like x squared equals, you know, but that's almost the even root property already, right? That's what it uses. So if you have x squared equals a number and it's already solved like that, then you can just do that. But in terms of actually completing the square, I would say it's probably not the optimal way, because we have a formula that we derive from completing the square, and this can always be used, right? So this can be used anytime. And maybe, you know, if you like the other methods, if the other methods don't work, right? If option number 1 and option number 2 don't work, right? Don't apply. All right. So that kind of gives you a you know, kind of a template, or a, you know, kind of a hierarchy of, you know, what to look for, right? So maybe even root might be the most straightforward, so check for that. If that doesn't work, try factoring. If that doesn't work, try the quadratic formula. Okay. All right, and by the way, let me just for the even root property, one other way to say that is you can say if b equals 0, right? So if the middle term is not there, you know, if you just have an ax squared and a c, that's when you use the even root property. So that's another way to say what I said here.